Right. Hi guys. So welcome back. Now we have completed 2013, 14 and 15. So we'll proceed to the next parts of the question. So next is 2016 paper. So 2016 essay fifth one BPOP. Right. They say B part and let's see. Consider the following reaction. Thermodynamic data supplied are not for the standard state. Okay, here underline the word not for the standard state because here you need to know that at standard state, which means at 25 degrees Celsius and 1 p.m. pressure, you have to use the symbol delta H theta, delta S theta, and delta G theta. Since this is not given under standard state, you have to use only delta H, right? Delta H, delta S, delta G, right? So you need to know this makes state because in the exam paper, some of you in a hurry, some of you will be in a hurry, so you will be writing just delta H theta, delta S theta. There you won't get marks just for writing the equation in that manner. So you have to say clearly what is happening here. So given the following data here, now see the first question. Calculate delta H and delta S for the reaction. Two molecules of carbon monoxide gas dissociates to give carbon solid plus carbon dioxide gas. State giving reasons whether the sign of delta S agrees with the reaction taking place. Okay. Now they are asking for the equation. Two carbon monoxide gas dissociates to give one mole of carbon solid. Carbon, it can be either graphite solid or diamond solid. But usually it's graphite solid here. And then carbon dioxide gas. Now they have given carbon solid reacted H2O gas to give carbon monoxide gas with H2 gas here, and CO2 plus H2 gas gives carbon monoxide with H2O gas here. So it's a little bit of mixture here, right? You need to get the concept really clear here. So here we have carbon solid, and here you have carbon dioxide gas here. So on the left hand side, you have two carbon monoxide there. So what I'm going to do is I'm going to see whether both the equations here in the table, like we have carbon solid plus H2O gas, which goes to carbon monoxide, and carbon monoxide gas and H2 gas here, right? This one's entropy. This one's entropy is given as enthalpy is 130 kilojoule mole minus 1. For the second one, we have carbon dioxide gas reacts with H2 gas to give uh, carbon monoxide gas with H2O gas here. So this one's enthalpy is 40 kilojoule mole minus 1. So let this one be a first equation, second equation here. Let these steps be there. So if you add all these equations here, 1 plus 2, here you can cancel out H2 over this side and H2 over here. Then H2O over here and H2O over here. So finally, the remaining ones are carbon solid plus CO2 gas gives 2 moles of carbon monoxide gas here. So they are asking this reaction here. See here. They are asking this reaction. But we received this, we got this reaction. So first we have to find out what is the enthalpy for this here. So enthalpy for the reaction is equal to delta H. Now see, 2 moles of carbon monoxide gas gives 1 mole of carbon solid and 1 mole of carbon dioxide. But we got carbon solid, carbon dioxide, 1 mole of carbon solid, 1 mole of carbon dioxide gas gives 2 moles of carbon monoxide gas. So if you can turn the arrow to the opposite side, the enthalpy level and all will change here. The enthalpy will change. So in this left to right direction, 130 kilojoule per mole. So if you bring to the reverse direction here, the sign will change. So here it is positive. So once you change the sign, it will be negative. Here also the same thing. So negative 130 kilojoule mole minus 1. Here negative 40 kilojoule mole minus 1. So therefore, the answer will be like this. Minus 130 kilojoule mole minus 1 plus minus 40 kilojoule mole minus 1. So your final answer will be minus 170 kilojoule mole minus 1. Understood? Here it comes in the opposite way. The arrows has to turn to the opposite way. So therefore, then only you can get the enthalpy change for this reaction. For this reaction, it is 170 to take in this manner, but they are asking this one, so it has to come to the opposite way. So the answer will come in negative. Since once you are calculating the enthalpy and all, I have said that there will be no heat exchange in the environment and no heat will be absorbed from the environment. So here you are going to do the same. So if you supply heat to one case, then if you reverse the same reaction, the sign will change, but the values won't change. Understood? The values will not change. The sign will only change here. So you have to understand that thing. Same way we can do for the entropy change here. So entropy change for the reaction bracket delta S. So this is equal to now we have 140 here. Oh, okay, we have 140 joule per mole per Kelvin, right? Here we have 50 joule per mole per Kelvin. Here it is also the same. In the same way, the sign will only be changed here, right? Here sign will change. So you can understand why it is a must to come negative. See here, we have carbon solid and H2O gas, 1 mole of H2O gas. Here we had 2 moles of H2O gas here. H2O, 2 moles of, which means 1 mole of carbon monoxide gas and 1 mole of H2 gas here. So molecularity here is 2. So here 1. So once you are proceeding from left to right here, the entropy change was positive here. So therefore plus 140. Now we are going to reverse it. So therefore it will be negative 140 joules per mole per Kelvin. So minus 140 joules per mole per Kelvin plus. Now here you cannot see why there is an entropy change or here or there. Here we have a case like left hand side and right hand side all are gases. Molecularity is also same. So you should know that once you are reversing it up, once you're reversing this reaction here, it will become negative. Just like the enthalpy change, we can consider it. But for this reaction, you can say what is happening to the entropy. Entropy depends on the physical state. Change in the physical state. So once there's a change in physical state, like for example, once a substance is going from solid to liquid, that is a positive enthalpy change. From liquid to gas, positive enthalpy change. But if you're moving to the if you're moving from gas to liquid, then liquid to solid, those and all will become negative. You can directly go from gas to solid also. That is also negative. You can move from solid to gas also. So gas to solid is sublimation. Here from solid to gas is sublimation. Then from gas to solid is deposition. So on that directions and all, you can get the entropy changes here, right? So here minus 50 joules per mole per Kelvin. So we'll add here up. So minus 190 joules per mole per Kelvin, right? So here we follow the enthalpy and the entropy change for the reaction one. And see here, they finish the question like giving reasons whether the sign of delta S agrees with the reaction taking place. You have to give this in here. The reaction is this. So we got the enthalpy change and the entropy change for this reaction now. And so they ask you whether this sign agrees with this reaction. Yes. Why? Because here molecularity is 2. we have 2 moles of carbon monoxide gas, which dissociates to give 1 mole of carbon solid and 1 mole of carbon dioxide gas. So here we had lots of gases here, and here there's a change in state, and here there's a reduction in state, reduction in some amount of states here. Now see here, for example, let's say we had 100 100 moles of carbon monoxide, right? Let's say we had 100 moles of carbon monoxide. Here we had 2, right? During the process, during the reaction process, 50 was distributed for the carbon solid. 50 moles was distributed for the carbon solid. Then the rest of them will come for one for the carbon dioxide. So initially we had a huge number of gaseous substance here. So during the reaction it got reduced. So therefore, when there's a reduction in the number of moles and all, in that case, and there's a change in state also, therefore the entropy becomes negative. So whether the sign agrees with the reaction? Yes. What is the reason? So there's a reduction in the number of gas molecules in the number of gas molecules during the reaction. Right? So this is the answer here. There's a reduction in number of gas molecules during the reaction. So the number of molecules here, the states and the number of molecules which are present there has been reduced. So therefore, the entropy will be in negative actually, right? There's a thing here. Right. Right. Now we see the third question. Yeah. Now see the second part of the question. By means of a suitable calculation, predict whether the reaction given in the part 1 above is spontaneous at 27 degrees Celsius. So the fellow who is actually responsible for the spontaneity is the delta G, which is Gibbs free energy, right? So Gibbs free energy change it indicates whether the reaction is spontaneous or non-spontaneous. So delta G is equal to delta H minus T into delta S. I didn't use theta here because they have already said in the question that they are not in the standard states. Yeah, they are not in the standard states. So delta G is equal. Now the enthalpy was 170 kilojoule mole minus 1 minus. Then here they are asking for the reaction at 27 degrees Celsius. So 27 degrees Celsius means it at Kelvin temperature is 300 Kelvin into delta S is minus 190 kilojoule mole minus 1 Kelvin minus 1. So I'm just dividing this one by 1000. Right. So delta G is equal to minus 170 kilojoule mole minus 1. Here these two zeros can be cancelled here. Here this zero can be cancelled here. So minus into minus plus 57 kilojoule mole minus 1. Here Kelvin and Kelvin will be cancelled here. Kelvin per Kelvin will be cancelled here. So delta G is equal to minus 113 kilojoule mole minus 1. So since the delta G is in negative value, since the delta G is in negative value, so therefore we can say the reaction is spontaneous at 27 degrees Celsius. Understood? So when delta G is negative, it is spontaneous. When delta G is positive, it is non-spontaneous. When delta G is 0, the system is said to be at equilibrium. Right? Therefore, the value is negative, so therefore it has to be spontaneous. So that's all for the 2016 past paper question here. Now see here, guys. Once you see from 2013 till now, the questions are being the same. Except the way of applying, the way of approaching is going to be different here. Now see, they gave certain reaction here, and in the previous papers and all, they have given the tables and all alone, and we have to just add and do it here. But see here, this time they have asked the reaction in the opposite way. They have asked the question in the opposite way. So once you consider each of those parts also, those are also going to be easy here. There is nothing hard here. Just seeing the data what they have given, then analyzing what we can do. Then after analyzing that part, we come to a conclusion like it is better to adapt or giving a thermodynamic cycle. That is also okay. Whether if you're giving an enthalpy level diagram, that is also not a problem. Whether Born-Haber cycle, that is also not a problem. So all those cases depends upon the way we approach. Some of you guys can think like, why can't we do this question in the thermodynamic cycle? Yes, you can do. You can do a thermodynamic cycle also. That is not a problem. So here I just did just to show you like it is easy to do in this manner also. So nothing hard here. So in 2016 and all, you can get the summary. In certain questions while we are doing here, you can understand like this is how the MCQs can also come. Certain MCQs are also there, just having the same concept as in the essay. In the essay, we have to write too much. they have to do it in within less than 2.5 minutes. So in that also we have certain questions in the past papers. We'll see. Right, now let's see the 2017 paper. Two 2017 SAB part. Right. In order to determine the standard enthalpy change, delta H theta of the reaction to sodium, 2 moles of sodium bicarbonate solid reacts to give, dissociates to give sodium carbonate solid, one mole of sodium carbonate solid and 1 mole of H2O liquid and 1 mole of H2O, 1 mole of carbon dioxide gas. The following experiment consists of 2 steps, step 1 and 2 are carried out at room temperature. Okay. Step 1, 0.08 mole of sodium bicarbonate solid was added to 100 centimeter cube of 1 mole decimeter cube HCl acid solution in a beaker. The maximum temperature fall was found to be 5 degrees Celsius. Underline the sentence, the maximum temperature fall was found to be 5 degrees Celsius. Okay, guys, see here. Once they said the temperature falls 5 degrees Celsius. Now you have to know whether this reaction is endothermic or exothermic. So that's what they are indirectly asking here. So the temperature had been to fall. That means that solution, after adding sodium bicarbonate to the solution of HCl, the temperature went down by 5 degrees Celsius. So the delta theta, which means the temperature change, has gone to 5 degrees Celsius. So it means it's like this. You take some amount of water in your hand and you add some glucose powder to it. So there at that time you can see your hands getting cooled out. So it means the solution tends to absorb heat from the environment. Like for example, if you add to your hands, like I said, like if you add sodium bicarbonate and water within your hand will start to get cooler on those contact area. It means that within that area, the solution tends to take heat from the environment. It tends to absorb the heat from the environment. So therefore, this reaction is tend to be endothermic. So this reaction is going to be endothermic. So therefore, delta H enthalpy change is going to be positive. The value is going to be positive one. Understood? Be careful here. Some of you can think if you are going to fall, if the temperature falls, mean sometimes delta theta can be negative. No, you're right, but consider the type of reaction. Whether is it endothermic or exothermic? If endothermic means it will take the heat from the environment, right? So it tends to take the heat from the environment. Since you're finding out all these things within an isolated system, you have to consider that there is no heat going to be released in the environment, no heat going to be absorbed from the environment. So therefore, since the temperature is decreased, you can say that particular solution, the particular reaction is going to be endothermic. Understood? So this reaction is going to be endothermic. So they have given the reaction also. And step 2, 0.04 moles of sodium carbonate solid was added to 100 centimeter cube of 1 mole decimeter cube HCl acid solution in a beaker. The maximum temperature rise was found to be 3.5 degrees Celsius. The maximum temperature rise. So underline that sentence also. The maximum temperature rise was found to be 3.5 degrees Celsius. Temperature rise. It means you can feel the heat. That means heat is being released in the environment. So therefore, that reaction is going to be exothermic. And they have given a reaction also for that, for sodium carbonate. Specific heat capacity of constant pressure, at constant pressure, and density of HCl acid solution are 4 joule per gram per Kelvin and 1 gram centimeter cube per centimeter cube respectively. Assume that the changes in volume and density of the solution after addition of solids in the above two steps are negligible. So therefore, the volume change is not to be considered here. Right. The first question. For this question, calculate the enthalpy changes. Calculate the enthalpy changes in kilojoule mole minus of the reaction given in step 1 and 2 above. Okay, now we are going to find out the enthalpy changes for the step 1 and 2. Now see here guys, they have given the density of the solution HCl, that is 1 gram centimeter minus 3. They have given the specific heat capacity of the solution, that is 4 per joule per gram per Kelvin. And they have given the temperature changes, the temperature change for the step 1 and 2, and the volume of the solution that they have used here. So in this case, first of all, once you consider the equation delta H theta, so enthalpy means the amount of energy released or absorbed divided by number of moles of the substance. It can be plus or minus here. Understood? So therefore, the amount of heat absorbed or released, you can give this symbol as Q and this one as N here. So therefore, delta H theta is equal to plus or minus Q over N. So you can, first of all, you need to find out for step 1. Heat, the temperature was decreased here. The temperature was decreased by 5 degrees Celsius. So therefore, heat is absorbed by the environment. So heat, amount of heat absorbed by solution. So Q is equal ms delta theta. So mass means you can find it from density. They have given the volume of the solution, that is 100 centimeter cube. So mass is equal to density is equal mass of volume. So if you bring the volume to the other side, it becomes multiplied. So density into volume into S into delta theta. So 1 gram centimeter minus 3 into 100 centimeter cube into the specific capacity was given as 4 joule per gram per Kelvin into the temperature change for this first step is 5 degrees C. Right? So see here guys, we have 5 degrees C now. So if you take temperature change, that 5 degrees C will be equal to the Kelvin temperature also. So there won't be any issue here. If you are taking Fahrenheit only, there will be a problem here. This values are not be changed. They are given for Kelvin and degree Celsius. So you can consider, I mean, both the change will be the same. It can be 5 degrees Celsius or 5 Kelvin. Both are same. Right? Now see. So the answer is like 2000 joule. So this can be equal to 2 kilojoules here. So 2 kilojoule of heat will be absorbed by the solution here. Right? 2 kilojoules of heat will be absorbed by the solution. Now you can find out the enthalpy. Enthalpy change